This is my automated litter box. I built this for a couple reasons. One is because I was tired of cleaning up litter that would get usually thrown out of the regular litter box, and also litter that was on the cat's feet that would get scattered throughout the house. Tired of dealing with that. And the other thing is I didn't like having to deal with the litter on a daily basis on the regular litter boxes. So I thought I would do something that would hopefully make my life a little more simple. So this is what I came up with. So let me show you how it works. So when the cats have to go, the first thing they do is they'll climb up the ladder here, and then they'll enter into the entrance like this. All right, so now let me show you how the litter box works. So to do that, you can take off the two top panels. Each one has a latch, and then they slide off. So here's what it looks like from up above. So when the cats come in the door here, they have to go down this carpeted ramp down to the bottom. Down there they have to make a U-turn, turn back around, come up the second ramp, and then jump through this opening here, which leads them into the main area. So the idea behind this is that when they are covering their litter and digging around in here, it's deep enough that the litter most likely won't get thrown over that ledge there into the stairway. But of course, when they do leave the box, there will be litter on their feet. So when they come out to this carpeted area to exit, the litter on their feet will hopefully fall off as they walk down the ramp, and then do the U-turn and then back up. So hopefully the litter falls off. But any litter that does come off during that process will roll down towards the back and not come out the door here. That's the idea. Next step is, how do you clean the litter box? So that's what the left side here is for. So you see the bottom half, we have a screen, and then we have a chute and a kitchen-sized garbage bag up here. So what we do is we rotate the entire thing to the left. All the litter will flow down. The clean litter will go through the screen into a big cavity in the back. All the poop and pee balls will ride up the ramp and get deposited into the garbage bag, and the garbage bag sits in another cavity back here. It holds about 2 weeks worth of poop, maybe 10 pounds-ish in a couple weeks is what I get. So about every 2 weeks I have to change this litter bag. Other than that, the only thing you have to do is rotate the litter box to the left to move all the litter to the left, and then to reset it, you rotate the whole thing back to the right, so all the litter comes back out of that cavity into the main area. So the next question is, how do we rotate the litter box to clean it? Easier said than done. The litter box itself weighs about 220 pounds, and I designed it to hold 120 pounds of litter, but right now it seems like I can get away with 80 pounds of litter. So the whole thing weighs 300 pounds, with 80 pounds of that moving from one end to the other as you rotate the box back and forth. I did it manually for about a year, and then I decided I had to automate it because it was too dangerous the way it was. So the way we do it now, very simple. It's all powered, so we turn power onto the system, the light switch, and then you just use your Tazo tea container or the control panel, and we can move it with using these two buttons. If we want to do it manually, we can use this button to rotate it to the right. We move it to the right. Goes down, and if you let go, it stops. If you want to go back to the left, rotate the switch to the left, and it goes to the left. So you can do this manually if you want. The other thing you can do, if it's centered and everything's normal, we have an auto button. Press the auto button. You can press it once, and it goes through the whole motions. So you can set this down, And what it will do is it will rotate all the way to the left to clear it. It will rotate back to the middle, and then I found that it doesn't, well, the poop isn't always perfectly round. It doesn't always roll as easily as you'd think. So I have it do a second dumping to try to get any of the poop that didn't go in the chute the first time. And then we rotate it all the way back to the right. Let's reset all the litter, and then let it sit there for maybe 30-45 seconds, and then we'll bring it back flat, and we're done. And right now I have it kind of on a pretty slow speed. It takes maybe 7 minutes, so I'll speed up the film here a little bit. Comes to a stop at the bottom, waits a couple seconds, then it will reverse. So now it comes to a stop, and it'll do a second dumping. All right, well, it's going. I'll show you a little bit about how the automation works. So what we're using here are 2 ball screws. And that thing right there is a ball screw, which is attached to the base here. And then the ball screws are mounted, there's one on each side, mounted in bearings here, and then over there. And they, in turn, are on this plate, which is a swing plate. So that swings in space. And this is kind of like the swing set, essentially. And then we have a motor attached here, and the motor is turning a gear, a sprocket, and then the sprocket drives 2 sprockets, one for each ball screw. So the 2 ball screws are essentially locked together with a chain so that they both move at the exact same time and distance, so they can't get off. Now it's at the very bottom, and we're going to give it about 30 seconds. And so we use position sensors. So you can see there's a position sensor that's lit up, letting the computer know that it's at the bottom. That one right there is the one to sense the middle. And then finally, here's the last position sensor that will activate to let us know when the box is at the very bottom. So now it's coming back up to the top to do its final reset. And the last thing I haven't shown you is the NEMA 4 panel. Actually, it's just a Christmas cookie box. This contains all the electronics that is jam-packed in there. So what we have in here is power supply. That's the PLC right there. Power supply for the PLC in the bottom, a power supply for the motor, and a whole bunch of fuses, a couple Zener diodes, and a couple relays in there to drive the motor. Anyway, that is the litter box. One last thing I thought I might show you if you're interested at this point. This is a computer model made of the litter box to help design the automation. So just kind of demonstrate what you can do with Excel. I thought was kind of cool. So what we've done here is we've created a visual model of the litter box. There's the litter box, here's the pivot, here's the screw rod, and the entrance to the litter box. The point of this model was to figure out how to design the screw rod, where to put it, and to see what kind of forces are going to be on it when we're using it. So I have some sliders over here I can use to control the attachment point here, where the nut is, where it attaches to the base, and also where the pivot down here, where the swing is. We can move that back and forth. So for example, if I want to move the connection point here to the left, I can slide the slider, oops, to the right. How about go that way first? So we can move it on down to the end, or we can move it down this way. And then similarly, we can do the same for the bottom connection point here by moving this. And then finally, what we can do is we can rotate the box through its motions. And as we're doing that, we can visually see the kinematics, what's going on, where the rod is, if it's long enough, if it's going to interfere with the door, that type of thing, or if it's going to stick in the ground. So we've got to make sure that it's actually going to work. Also, we want to monitor the forces. So here's the total force right here on the pivot point. Whereas right now there's 336 pounds on this, if the litter box weighs about 300. And this is the force on the ball nut, which is going to be axial here. So what we can use this slider here to rotate the box. So I can rotate it clockwise here. And you can see the forces change down here, kind of getting larger. And at any point, we can again slide the sliders around to see what the forces are. So you can play with this and come up with a solution that optimizes for the forces. And we can rotate it back the other way. I think that's about as far as it goes right there, 70 degrees. So you can see, again, we can move the nut around, move the bottom around, see what happens. So anyway, kind of a useful tool. Probably would not have been able to build this without this computer model here.